What if you could survive just 1 hour on Mercury before your body literally cooks from the inside out, or experience the crushing pressure of Venus that would compact your bones like a tin can? Today, I'm taking you on the most extreme survival challenge ever attempted, spending 24 hours on every single planet in our solar system, and I'm going to show you exactly what would happen to your body, hour by hour, based on real science. Buckle up, because this journey is going to be absolutely brutal. Let's start our journey on Mercury, the closest planet to the Sun. The moment you step onto Mercury's scorched surface, you'd immediately notice something terrifying. The ground beneath your feet is radiating heat at 430 degrees Celsius on the day side. Within the first hour, even with the most advanced spacesuit humanity could build, the extreme temperature would start overwhelming your cooling systems. Your suit would struggle to dissipate the intense heat, and you'd feel like you're standing inside a furnace. By hour 3, if your suit somehow survived, you'd witness the sun appearing almost 3 times larger than it does from Earth, beating down with radiation 7 times more intense. Around hour 6, your body would be fighting severe dehydration despite your suit's water recycling system, as the cooling process would be consuming water at an unsustainable rate. By hour 12, you'd experience the bizarre phenomenon of Mercury's rotation. You've only moved through a tiny fraction of a Mercurian day, which lasts 176 Earth days. The temperature differential would start affecting your suit's integrity as you move between extreme heat and cold zones. By hour 18, muscle fatigue would set in from the constant strain of maintaining temperature regulation and dealing with Mercury's gravity, which is only 38% of Earth's. As you approach hour 24, you'd be exhausted, severely dehydrated, and your suit would be on the verge of catastrophic failure. Mercury doesn't have an atmosphere to protect you from micrometeorites either, so you'd be constantly at risk of puncture. Congratulations, you survived Mercury, but the nightmare is just beginning. Next up is Venus, and let me tell you, this is where things get absolutely horrifying. Venus is often called Earth's twin, but it's actually Earth's evil twin. The moment you enter Venus's atmosphere, you'd be descending through clouds of sulfuric acid. That's right, acid rain that would eat through most materials. Landing on the surface, you'd immediately face a pressure 92 times greater than Earth's sea level, equivalent to being 900 meters deep in Earth's oceans. In the first hour, this pressure would be compressing your suit with the force of a car sitting on every square inch. The temperature here is 465 degrees Celsius, hot enough to melt lead. Your suit would need to be an engineering miracle just to survive minutes. By hour 2, the crushing pressure would be causing microfractures in your suit's structure, and you'd hear creaking sounds that would terrify you. The heat would be penetrating through any insulation, making you feel like you're being slowly roasted alive. Hour 4 would bring severe psychological stress as the thick atmosphere blocks out the sun completely, leaving you in an eerie orange twilight. The wind speeds at your level would be relatively calm, but you'd know that above you, 360 km/h winds are ripping through the upper atmosphere. By hour 8, your suit's structural integrity would be critically compromised. The combination of heat, pressure, and corrosive atmosphere would be eating away at seals and joints. You'd be experiencing severe muscle fatigue from fighting against the pressure just to move. Hour 12 marks the halfway point, and you'd be dealing with sensory deprivation in the monotonous, crushing environment. By hour 16, your life support systems would be failing. The heat would have degraded your cooling systems beyond repair, and you'd feel your core temperature rising despite all technological interventions. Hour 20 brings delirium as your body struggles with the extreme conditions. Your muscles would be screaming in pain from the constant effort to move in the high-pressure environment. As you reach hour 24 on Venus, you'd be barely conscious, your suit on the verge of implosion, and every breath would feel like your last. Venus is, without question, the most hostile surface in our solar system, and you just survived it by the skin of your teeth. Now we come to Mars, and finally, we get a bit of a break, relatively speaking. Mars is cold, really cold, but at least it won't immediately crush or cook you. As you land on Mars, the first hour would feel almost peaceful compared to Venus. The temperature is a chilly -60 degrees Celsius on average, but your suit can handle this. The atmospheric pressure is only 0.6% of Earth's, so you're essentially in a near vacuum. In the first 3 hours, you'd be marveling at the rusty red landscape and the significantly reduced gravity, only 38% of Earth's, same as Mercury. You could jump 3 times higher here. By hour 6, you'd start noticing the effects of cosmic radiation. Mars has no magnetic field and barely any atmosphere, so you're being bombarded by radiation from space. Hour 9 would bring the reality of Martian dust. This stuff is extremely fine and gets everywhere. It's also potentially toxic due to perchlorates in the soil. Your suit would be covered in it. By hour 12, you'd experience a Martian sunset. And here's something beautiful. The sky would turn blue near the sun, the opposite of Earth, due to the way dust particles scatter light. Hour 15 brings the brutal Martian night. Temperatures would plummet to minus 125 degrees Celsius. Your suit's heating system would be working overtime. By hour 18, you'd be dealing with the psychological effects of isolation in this barren, dead world. The silence would be absolute. Hour 21 would bring extreme fatigue. Even though Mars is more hospitable than Mercury or Venus, the combination of radiation exposure, temperature extremes, and the constant stress of being in a hostile environment would be taking its toll. As you complete hour 24 on Mars, you'd be exhausted, but alive. Mars is survivable with current technology, which is why it's our top target for future colonization. Moving on to Jupiter, but here's the thing. Jupiter doesn't have a solid surface. It's a gas giant. So we're going to experience the descent into Jupiter's atmosphere, which would be the most spectacular and terrifying ride of your life. In the first hour of descent, you'd be passing through Jupiter's upper atmosphere, seeing the most magnificent cloud formations in the solar system. The temperature would still be freezing, around minus 145 degrees Celsius. By hour 3, you'd be descending deeper, and the pressure would start building. The clouds would become denser, and you'd be experiencing turbulence unlike anything on Earth. Jupiter's atmospheric winds can reach 640 kilometers per hour. Hour 6 brings you into the zone where pressure is similar to Earth's surface, but the temperature is rising rapidly. You'd be seeing lightning bolts 1,000 times more powerful than Earth's lightning. By hour 9, the pressure would be crushing. Now at several times Earth's atmospheric pressure and climbing. The temperature would be hundreds of degrees and rising. Your descent vehicle would be struggling against the increasing density of the atmosphere. Hour 12 marks a critical point. You're now so deep that the hydrogen around you is starting to behave strangely due to the immense pressure. The temperature is now over 1,000 degrees Celsius. By hour 15, you'd be experiencing pressures hundreds of times greater than Earth's surface. Your vessel would be groaning under the stress. The hydrogen around you would be transitioning into a liquid metallic state. Hour 18 brings you to the point of no return. The pressure is now millions of times Earth's atmospheric pressure, and the temperature is hotter than the surface of the sun. No material known to humanity could survive these conditions. Hour 24 on Jupiter means you're now part of the planet itself, compressed into the exotic matter that forms this gas giant's core. By hour 21, theoretically, you'd be dissolved into the metallic hydrogen ocean that makes up Jupiter's interior. Jupiter doesn't kill you, it absorbs you. Saturn is next, and it's similar to Jupiter but slightly less extreme. The first hour in Saturn's upper atmosphere would be spectacular. You'd be flying through the famous rings, dodging chunks of ice and rock. The view would be absolutely breathtaking. By hour 3, you'd be descending into the atmosphere proper. Saturn's winds are even faster than Jupiter's, reaching up to 1,800 kilometers per hour near the equator. The turbulence would be insane. Hour 6 brings increasing pressure and temperature, though not quite as intense as Jupiter's. You'd be seeing Saturn's equivalent of the Great Red Spot, massive storm systems that dwarf Earth's hurricanes. By hour 9, the pressure would be building to crushing levels, and the temperature would be rising past 1,000 degrees Celsius. Your descent vehicle would be fighting for survival. Hour 12 marks the transition zone where hydrogen starts becoming metallic, just like Jupiter. The conditions would be becoming increasingly hellish. By hour 15, you'd be experiencing the same fate as Jupiter, pressures and temperatures that would destroy any known material. Hour 18 through 24 would see you descending deeper into Saturn's interior, eventually being crushed and absorbed into the planet's exotic matter core. Saturn is beautiful from a distance, but it's just as deadly as Jupiter up close. Uranus presents a unique challenge because this ice giant is tipped on its side, rotating perpendicular to its orbit. The first hour in Uranus's atmosphere would be eerily calm compared to Jupiter and Saturn. The temperature at the cloud tops is minus 224 degrees Celsius, making it one of the coldest planets. By hour 3, you'd be descending through layers of methane ice crystals that give Uranus its distinctive blue-green color. The winds here are relatively calm near the equator, but can reach 900 kilometers per hour in other regions. Hour 6 brings you deeper into an atmosphere of hydrogen, helium, and methane. The pressure is building, and the temperature is rising, though not as dramatically as the gas giants. By hour 9, you'd reach what scientists call the mantle, a hot, dense fluid of water, methane, and ammonia ice under extreme pressure. The temperature here would be several thousand degrees despite being called an ice giant. Hour 12 marks your descent into truly exotic conditions. The pressure would be crushing, and the environment would be completely alien. By hour 15, you'd be experiencing pressures hundreds of thousands of times Earth's atmospheric pressure. Your vessel would be failing. Hour 18 through 24 would see you descending toward Uranus's rocky core, if it has one. The conditions would be so extreme that you'd be crushed long before reaching it. Uranus might seem calm and serene from space, but its interior is just as hostile as any other planet. Neptune, our final stop among the major planets, is the windiest planet in the solar system. The first hour would immediately show you why. Winds screaming past at 2,100 kilometers per hour, faster than the speed of sound on Earth. The temperature at the cloud tops is minus 214 degrees Celsius. By hour 3, you'd be battling the most violent atmospheric conditions in the solar system. The Great Dark Spot, Neptune's massive storm system, would be a terrifying sight. Hour 6 brings descent into the deeper atmosphere with its brilliant blue methane clouds. The turbulence would be beyond anything experienced on any other planet. By hour 9, pressures would be mounting rapidly as you descend into the ice giant's interior. The temperature would be rising to thousands of degrees. Hour 12 marks your entry into Neptune's mantle of superionic water ice, an exotic form of ice that exists under extreme pressure and temperature. By hour 15, you'd be experiencing the same crushing fate as Uranus. The pressure would be destroying your vessel molecule by molecule. Hour 18 through 24 would see you compressed into the mysterious core of Neptune, possibly made of rock and ice at unimaginable pressures and temperatures. Neptune's beauty hides a violent, deadly interior. So there you have it, 24 hours on every planet in our solar system. From the scorching heat of Mercury to the crushing depths of Neptune, each world would kill you in its own unique and terrifying way. The reality is that our solar system is incredibly hostile to human life. Earth isn't just special, it's a miracle. We exist in a narrow band of conditions that allow liquid water, breathable atmosphere, and protection from radiation. Every other planet would kill an unprotected human in seconds to minutes. This journey shows us not just how deadly space is, but how precious and fragile our home planet truly is. If this extreme survival challenge taught us anything, it's that we need to protect